We use our phones literally every single second of the day. We're sending texts, we're streaming shows, we're making calls, and it all just kind of works. It feels like magic, right? Well, that's not magic. It's an absolutely incredible feat of engineering. So today, let's pull back the curtain and find out what actually happens every time you tap that send button.
Really think about that. You type a message to a friend who's thousands of miles away, you hit send, and ping, they've got it. Almost instantly. How? How is that even possible? It seems to just vanish into thin air and reappear on the other side of the planet. Well, we're going to demystify that magic step by step.
All right, so our story begins exactly where you'd think it would, right there inside your phone. Before your message can do anything else, it has to transform from a physical thing, an idea in your head, letters on a screen, into something that can travel through the air. And the fuel for this whole adventure? It's your mobile data. When you're not hooked up to Wi-Fi, this is the connection that keeps you online. It's the internet that your phone company provides, and it's what lets your phone talk to the rest of the world, no matter where you are.
Okay, so here's the first real bit of wizardry. Your message, your text, it starts out as just a bunch of tiny electrical signals, basically a flow of electrons buzzing around on your phone's circuit board. But how do you get it out of the phone? That's where the antenna comes in. It's like a translator. It takes those electrical signals and converts them into invisible radio waves, launching your message into the air at pretty much the speed of light.
So your message is now an invisible radio wave, zipping through the air. Its very first stop is the closest cell tower. But what happens next? Well, this is the most surprising and honestly the coolest part of the whole journey. You probably think it's wireless all the way, right? Not even close.
And boom, there it is. This is the big secret. Your wireless communication isn't actually all that wireless. In fact, most of the trip happens through a mind-bogglingly huge network of physical, high-speed cables buried underground and lying on the bottom of the ocean. The wireless part, that's really just the very first step out of your phone and the very last step into your friends.
So let's trace the whole path, right? Step 1, a short wireless hop from your phone to a cell tower. Step 2, that tower converts the signal and blasts it through a massive network of fiber optic cables. We're talking across continents, under oceans, at insane speeds. Step 3, it gets routed through that wired network to a tower near your friend. And only then, step 4, does it make that final wireless jump from that tower to their phone. Crazy, huh?
Now you might be wondering, how on earth does this system handle millions, even billions of people using their phones all at the same time without turning into complete and utter chaos? Well, the answer is in the name itself, the cellular network. The architecture is pure genius.
So the way it works is that the entire landscape is broken up into a grid of smaller areas, or cells. It kind of looks like a honeycomb. And each one of these cells has its own cell tower or base station. This simple idea is what makes the entire system possible. When you use your phone, you're really just talking to the tower in whatever cell you're currently in.
But why do it this way? Why not just build one giant, super powerful tower for a whole city? Well, by using lots of smaller cells, the network can actually reuse the same radio frequencies in different cells that aren't touching each other. This multiplies the network's capacity immensely. Plus, it means your phone doesn't need a huge, power-hungry antenna because the nearest tower is never that far away. It saves your battery and makes the whole thing work way more efficiently.
This is the perfect way to think about it. The cell tower is the teacher, and all our phones are the students. If everyone just shouted at once, total chaos. The teacher wouldn't understand a thing. So there are rules, a protocol. Your phones agree to take turns, or speak on slightly different channels, or use special codes so the tower can hear everyone clearly. It's what keeps the conversation from turning into noise.
And what happens when you're, say, driving in a car, and you move from one of these cells into the next one? The network performs this brilliant little trick called a handoff. Before the signal from the tower you're leaving gets too weak, the network seamlessly passes your connection over to the tower in the cell you're entering. It happens in milliseconds, so your call doesn't drop and your video doesn't buffer. It's just seamless.
Now, this amazing technology didn't just appear out of nowhere. It's been evolving at a wild pace for decades. Each new generation has completely changed the game, unlocking things we now just expect to be able to do. Let's take a quick look back. It all started way back in the 80s with 1G. Think those giant car phones that could only make analog voice calls? Then came 2G in the 90s, which went digital and gave us the miracle of text messaging, SMS. The 2000s brought us 3G, and that was the real game changer that finally put the internet, a slow internet, but the internet, in our pockets. Then 4G in the 2010s made everything fast. Suddenly, we could stream high-quality video.
And now, 5G is setting the stage for a future where it's not just people, but billions of smart devices that are all connected.
So that brings us to today, and the absolutely mind-blowing opportunities being built on this latest generation of network technology. And trust me, it's about way more than just faster downloads on your phone.
I mean, just look at the numbers. Potential speeds over 10 gigabits per second. That is just staggeringly fast. But it's also about the incredibly low latency. The lag, or delay, is almost zero. That combination of speed and responsiveness isn't just a small step up, it's a massive leap that makes entirely new technologies possible for the first time.
So what does all that power actually get us? Well, we're talking about things like self-driving cars that can talk to each other and the road in real time to prevent accidents. Truly smart cities that manage traffic and power grids with perfect efficiency. A real Internet of Things, where everything from your home appliances to factory sensors are connected. Even things like remote surgery and advanced healthcare become possible. This is the world that 5G is making a reality.
So we've gone from a tiny electrical spark in your phone to a radio wave, through cables under the sea, across the globe, and back into the air to reach its destination. It's an amazing journey that connects two people. But as this tech continues to evolve, as it connects not just people but things, it really makes you stop and think, what does our world actually look like when everything is connected?